Alright guys, so the learning target today is really that we're going to study margin of error. Okay? What we're hoping that you do is we're hoping that you can understand what margin of error is and be able to calculate it. And it's not that big of a deal to do in reality, and really you guys kind of already know what it is. So if I were to say student A had 67% of people, 67% of my sample said that they voted for student A for Homecoming King. Right? Well, that's an estimate. I think, based on this sample, that my population is going to show this much, this many people in favor of that person. Margin of error is something that you often see at the bottom of a graphic on TV. So a Gallup poll will say 51% of people are going to vote for Obama in the next election. Before the last one, I guess. But then at the bottom it says plus or minus 3%. Does anyone know what that plus or minus 3% means? Yes?
Like, it can be more or less?
It can be more or less. Good. How much more, how much less? Anybody? Caleb?
3% more, 3% less.
So if I said 51% are going to vote for this person, it could be as low as 48, and it could be as high as 54. And the idea is that we don't know for sure because we don't ask everyone in the population. Hence, what a statistic is. A statistic is an estimate of a population parameter. Parameter means it's a rule. I've talked to everyone. You can only get them with census. So we're going to define a few words here, and then we are going to do a couple margin of error problems. First word, point estimate. A point estimate is a single value that estimates a population parameter. And you already know some of these. You know that X bar is the sample mean, right? And you know that mu is our population mean. Therefore, X bar is a point estimate of mu. If I gave all 25 of my students the opportunity to go out and randomly sample people in our school about who they voted for Homecoming King, you would all get different percentages, or most of you might get different percentages. There's a chance you could get the same thing. But if you all sampled, you'd get different percentages. Yet every single one of your percentages, every single one of your average number of people that said they voted for so-and-so for the Homecoming King provides a point estimate. It's a single value. Okay? So in the, if you're talking about the presidential election, the last presidential election, and you came out with a poll that said 51% of people are planning to vote for Obama. So if you said 51% of people then your point estimate is 51. And this leads us to our next definition, which is an interval estimate. An interval estimate is what is going over a range of information. So an interval is a range. An interval estimate is a range of values that the population parameter lies between. So if we one more time revisit our example of the national election last year, if I had a poll that said 51% of people plan to vote for Obama, plus or minus 3%, this is still a point estimate. My interval estimate starts to look like 48 is less than my average is less than 54. So my guess is that the average number of voters, or the number of voters really, mu may not be exactly what we're looking for here, but typically it's your variable in the middle. Remember, this is what we call a compound inequality. Okay, so your interval estimates are going to be compound inequalities. They're going to have your lower number and your higher number here, and the population parameter up there. Going back to the point estimates, the other point estimate that I want to focus on right now is that S is our sample standard deviation, and sigma is our population standard deviation.